When we're talking about the structure for NaCl, we're normally talking about a crystal. And a crystal is made up of a bunch of repeating formula units, also called unit cells. So a formula unit for NaCl might look like this here. So the sodium lost the valence electron to the chlorine. It lost that electron, it became positive. Electrons are negative, so the chlorine has an extra one, it now has a negative charge. And that positive and negative, they attract to form the chemical bond. We put the brackets around the chlorine to show that these electrons aren't shared. They're all around the chlorine. So this is our formula unit here. And if you look at our crystal of NaCl, you'll see that here we have the green, that would be a chlorine, and the purple, those are the sodiums. So when you look at this chloride ion right here, it's difficult to tell which one of these sodiums is attached to it based on our formula unit. We have a 1-to-1 ratio. And overall, in this crystal, there is a 1-to-1 ratio for the sodium ions and the chloride ions. Because of that, we don't really talk about molecular geometry or shape here. We talk about the arrangement of the ions in the crystal. For example, this is considered a cubic crystal. If you've ever looked at salt crystals closely, you'll see that they're little cubes. That's because of the arrangement of these ions in the NaCl crystal. If we put NaCl in water and let it dissolve, the crystal that would break down into the ions, Na plus and Cl minus. We'd write AQ after each one, meaning aqueous, to show that they're dissolved in water. So once the sodium chloride dissolves in the water, it breaks apart, it dissociates into the sodium and chloride ions, we don't have a crystal anymore. These are surrounded by water molecules. If we let the water evaporate, we'll go back to having solid NaCl, and we'll have our crystal again. This is Dr. B with the structure for NaCl, and thanks for watching.